There's been a major drive for digitalisation of energy system measurements for a number of years now, and this has been particularly emphasised in the past year by the Energy Systems Catapult. The digitalisation of data opens up lots of new possibilities for network operators and end energy consumers. For example, it can assist with renewable energy connections to the grid, helping with forecasting of those resources over time. Using synaptic technology, we get a clear view of relatively basic aspects of the system, such as power flows and constraints in the system. This alone will go a long way to maximising the number of low-carbon sources of energy that can be connected to the grid. We will also learn more subtle aspects about the running of the system and how to forecast and optimise the operation. We're expecting relatively quick return on investment for our conductor monitoring and dynamic line rating solutions, but even that's a relatively basic application of our technology. I'm very interested in what we can learn in the coming months when we start analysing data from wind farm installations and other applications. I expect that we can uncover new and interesting phenomena, especially by combining electrical and mechanical measurements. We're also researching some of the more radical opportunities from data analysis work. So this can include detecting and reacting to oscillations from converter interface generation sources. System operators presently have only a high level and relatively slow moving picture of the system. This approach has been acceptable when dealing with a couple of dozen generators in the system, but it just won't scale to the radical changes that the system is undergoing, especially due to the massive increase of distributed low carbon generation. For example, to quantify this level of significant change, one of the metrics that we can look at to evaluate the stability of the grid is how susceptible it is to loss of generation, and that's already declined over the past 10 years from about 1.7 gigawatts to typically about 1.1 gigawatts. It can involve a lot of additional infrastructure, such as requiring a robust time synchronization source, which can have its own inconveniences, requiring conventional telecoms equipment such as switches and routers, and also it might even require the building of an entirely new substation. So that's why the costs are so high. Synaptic's solution avoids most of these exceptionally high costs, but also maintains a very high measurement fidelity. The combination of electrical and mechanical measurements combined also makes a lot of sense for many customers. This opens up a lot of possibilities for combined data analytics on these two types of measurements. This can really help deliver a new class of condition monitoring. We make visibility of the power system much more convenient for our customers through our cost-effective and very convenient hardware solutions, combined with our bespoke software that is designed to handle the level of data that's produced.